to this lesson. I'm your teacher Agnes, and today we are going to be discussing about measuring temperature. Now, at the beginning of the topic of thermal expansion, we talked about what temperature is. Can you remember what temperature is? So we said that temperature is the degree of hotness or coldness of a body on a chosen scale. Remember? And then we said that the SI unit of temperature is Kelvin. However, temperature can also be represented in degrees Celsius and degrees Fahrenheit. Then we went ahead and said that the instrument that is used to measure temperature is known as a thermometer. Now, in this lesson, we are going to be exploring the temperature scales. We have two main scales that are used, which is degree Celsius and Kelvin scale. Degree Celsius scale and Kelvin scale. Then you're also going to look at the different types of thermometers that we have and how each one of them is designed to serve its purpose. So to begin with, like we have said, we have two types of scale that we are going to focus on, which are the Kelvin scale and then the degrees Celsius scale. Okay? Now, when we talk about the Kelvin scale, this is the scale that is used by most scientists. Now, the least temperature that can be measured, that is possible to be measured, is equivalent to 0 Kelvin, okay? So the least temperature that can ever be measured or can ever be attained by any substance is 0 Kelvin. Now this temperature, 0 Kelvin, is actually known as the absolute zero temperature, okay? The absolute zero temperature. Now, at this temperature, the particles in a material, okay? The particles in any material have zero energy. Now, I need you to stick with me here as we explore this further. Remember we said that the kinetic energy of substances increase as temperature increases. And when the temperature is reduced, the kinetic energy is also reduced. So it is possible to reduce the kinetic energy of the materials to 0. And when that happens, it happens at 0 Kelvin, which we call as absolute zero temperature. So absolute zero temperature is the temperature where the particles of the materials of any material have 0 energy, and the value of that temperature is 0 Kelvin. Now, if you use the degree Celsius scale, then this temperature, the absolute zero temperature, is actually equal to negative 273 degrees Celsius. So negative 273 degrees Celsius is equivalent to 0 Kelvin. So it is possible to convert between Kelvin and 270 degrees Celsius. So if you look at this, if you want 1 Kelvin, then you will add 1 here, right? So that you have negative 272. So anytime you are converting from Kelvin to degrees Celsius, then you notice that degrees Celsius is lower than Kelvin. So if you have like 20 Kelvin and you want to convert that to degrees Celsius, then the value of the degrees Celsius is going to go high. So as you convert from Kelvin to degrees Celsius, you add. So the difference between Kelvin and degrees Celsius is 273 divisions, all right? So as you convert from Kelvin to degrees Celsius, you subtract 273 from the given, value. And then as you convert from degrees Celsius all the way to Kelvin. Remember, Kelvin is denoted by capital K. Then we add 273. So if you have 0 degrees Celsius and you want to convert it to Kelvin, then you have to add 273 so that you get 273 Kelvin. So that is another point that you can use to remember that 0 degrees Celsius is equal to 273 Kelvin. Okay, 0 degrees Celsius is equal to 273 Kelvin, but 0 Kelvin is equal to negative 273 degrees Celsius. So now we are going to do some conversions and practice how to do this. So now we are going to convert between degrees Celsius and Kelvin. So given 26 degrees Celsius, we need to convert this to Kelvin. So to convert from degrees Celsius to Kelvin, we add 273. So our new temperature will be 26 plus 273, which is equal to 299 Kelvin. So this is what I used to remember. If you are converting from C to K, C is lower in the alphabet to K, which is higher in the alphabet. So for you to move from a lower letter in the alphabetical order to one that is higher, then you need to add something. So you add 273. So 120 degrees Celsius to Kelvin, then we will have 120 plus 273, and this will be equal to 393 Kelvin. Again, moving from a lower letter to a higher letter, we add. Now the opposite is true when it comes to converting from Kelvin to degrees Celsius. You're converting from a higher letter to a lower letter. So you have to downgrade, you have to subtract. So here we will have 1 minus 273, which is equal to negative 272 degrees Celsius. Then 360 Kelvin, 2 degrees Celsius, this will be equal to 360 minus 273, which is equal to 87 degrees Celsius. So that is how you convert between degrees Celsius to Kelvin. So now that we have known about the two scales that we use when measuring temperature, we are now going to explore the different types of thermometers that we have and how they are designed for different purposes. Now this is a liquid in glass thermometer. This is a common thermometer that we use in our laboratories. So this liquid in glass thermometer, like the word suggests in it, we have a liquid which is inside the thermometer. So what happens is that if you have hot water in a beaker and then you place the liquid inside the thermometer gets heated and rises to a certain level. And then when it has rose, based on the temperature of the water, it will get to a certain level and not rise any further. So once you read the value coinciding to the level of the liquid, then you are able to determine the temperature of that liquid, the temperature of the water. Now this liquid that we use in a liquid in glass thermometer is not just any other liquid. It must have certain properties. We actually call it a thermometric liquid. The word thermometric is derived from a thermometer. So we are going to look at which are these properties, okay? Properties of a thermometric liquid. This is how you spell thermometric liquid. So this liquid must have certain characteristics for it to be used in a thermometer. So number one, the liquid being used in a thermometer must be visible, okay? The reason why it has to be visible is because it is the one that we observe. We observe its level, and when it stops rising, we check the degrees Celsius that it coincides to. So if it is not visible, then we will not be able to take the reading, okay? so it has to be visible. Number 2, it should not, okay, it should not wet the glass. Remember the thermometer is made of glass. Now the liquid that we use should not wet the glass. The reason why this should not happen is because if it wets the glass, then it is going to leave traces of itself along the glass. And that means that you're not able to take accurate readings. And this makes it, remember when we learned about force, we talked about cohesive forces and adhesive forces. And we said liquids like water have stronger adhesive forces when they are in contact with glass. Water just wants to attach itself to glass, and that makes it a reason why we cannot use water in a thermometer, and also because water is not visible. Okay, so a liquid like mercury is perfect for use in a thermometer because 1, it's visible, 2, it has strong cohesive forces and does not wet the glass. Now another property is that it should have a wide range of temperature. A wide range of temperature. Now what does this mean? Now remember, this liquid or this substance that we are using in the thermometer must be in liquid form for us to use it in the thermometer. Once it boils, it turns into a gas and cannot be used in the thermometer. When it freezes, it turns into a solid and cannot be used in the thermometer. So the liquid that we choose must have a huge gap between the melting point and the boiling point. So we say that it should have a low freezing point and a high boiling point so that there is a wide range of temperature that it can measure, because if we use it past its boiling point, if we use it to measure a temperature that is above its boiling point, when we put it in a substance whose temperature is to be measured, it will boil and we will not be able to get the correct temperature. And when we put it in a substance that has less temperature than its melting point, it is going to freeze into a solid and we will not be able to use it to determine the temperature. So this liquid should have a low freezing point and a high boiling point, which also means that it should have a wide range of temperature. Then number 4, the liquid that we use should be a good conductor of heat. Good conductor of heat. Alright, good conductor of heat. So, a substance that is a good conductor of heat is able to react with the slightest changes in temperature. So if you dip it in hot water, it will be able to notice that the temperature is now hot and it will react to that by rising. Okay, it should be a good conductor of heat. Then finally, it should expand and contract uniformly. Okay, it should contract and expand uniformly, unlike water. Okay, so this actually gives you so many reasons why we cannot use water in a thermometric liquid. 1, water is not visible. The thermometric liquid needs to be visible. 2, water wets the glass. The thermometric liquid should not wet the glass. 3, water has a small range of temperature, but the thermometric liquid should have a wide range of temperature. You see, water melts at 0 degrees Celsius and boils at 100 degrees Celsius. So it can only measure temperatures between 0 and 100. If you use it to measure a temperature of 120, it will boil. If you use it to measure a temperature of negative 10 degrees Celsius, it will freeze. So water does not have a wide range of temperature. Another thing is that water is a poor conductor of heat. Okay, so that's another disqualification for water. Then water behaves or rather expands and contracts abnormally between 0 and 4 degrees Celsius. So it does not expand and contract uniformly. Can you imagine a case where you're using a thermometer that has water in it, and then when you dip it in a substance that is at 4 degrees Celsius or at 3 degrees Celsius. So when water gets to 4, instead of now contracting, it expands. You see, you will take the wrong reading. All right. So if you're asked for reasons why water should not be used in a thermometer, then all those are the reasons. So which liquids do we use? So the two most commonly used liquids in a thermometer are alcohol and mercury. But between alcohol and mercury, mercury is the best, okay? Because unlike alcohol, mercury satisfies all these characteristics, okay? The advantages of mercury are more. Mercury is more visible, it does not wet the glass, it has a wide range of temperature, it's a good conductor of heat, and it expands and contracts uniformly. In fact, alcohol has all these as disadvantages. It is not very visible, but color can be added to it. It slightly wets the glass. Its range of temperature is not as wide as that of mercury. It is not a good conductor of heat, and it has some slight irregularity when it comes to expansion and contraction, only that it is not as adverse as that of water. So there are only two advantages of using alcohol over mercury, one being that alcohol can measure temperatures that are lower than mercury. Alcohol has a melting point of negative 115 degrees Celsius, while mercury has a melting point of negative 39 degrees Celsius. So any temperatures below negative 39 degrees cannot be determined using mercury because mercury turns into a solid at negative 39 degrees Celsius. So below negative 39 all the way to negative 150 degrees Celsius, those temperatures can be measured using alcohol, okay? So alcohol can measure very low temperatures unlike mercury. But then also another advantage is that mercury has a boiling point of 375 degrees Celsius, while alcohol has 78 degrees Celsius. So alcohol cannot measure temperatures above 78 degrees Celsius, but mercury can measure temperatures up to 375 degrees Celsius. So that's the other thing. Alcohol is used when determining very low temperatures, and mercury is used when determining high temperatures. So this is the advantage of alcohol against mercury. Another reason is that alcohol is also cheaply available as compared to mercury, which is very expensive. So now, in this liquid in glass thermometer, which is the common thermometer that we use, it has some features that makes it possible for it to be very effective. So now we are going to look at the common features of a common thermometer. Now we've already seen how a common thermometer looks like. For the purpose of learning, we are going to use this diagram. So in a common thermometer, we have four main components. Number one is a bulb. Number two is mercury or the thermometric liquid. Then we have the capillary bore, and then we have the glass stem. So what is the purpose of this bulb? So the purpose of the bulb is to hold the mercury, okay? So the bulb carries the thermometric liquid. In this case, it carries the mercury. So that is where the mercury is held. So when temperatures are increased, the mercury rises from the bulb all the way to the required level based on the temperature. Then the mercury acts as a thermometric liquid. So it is this liquid that rises to the required temperature. Then we have the capillary bore, like you can see it is the inner part, and that is the path along which the mercury is flowing. So it allows the mercury to expand and, to expand and contract along its path. To expand and contract. So when mercury is rising to whichever level, it rises along the path of the capillary bore. Now the capillary bore is made very narrow, okay? It is very narrow to increase accuracy, to increase the degree of accuracy. Then the glass stem is the outer glass part, which actually is the one that houses, the capillary bore, and then it also acts as a magnifying glass so that it is easy for the readings to be taken. Remember, those small deviations on the thermometer are very tiny. So the glass stem acts as a magnifying glass so that it is easy for the scale to be read. Okay? Now, these are the features of a common thermometer, and it is used in the laboratory. But we have another thermometer that is used in the hospitals, and it is known as a clinical thermometer. So what is different about a clinical thermometer when you compare it to a common thermometer? So that is what we are going to discuss next. Now, this is a different type of a thermometer known as a clinical thermometer. It is a type of thermometer that is used in hospitals, or rather was being used in hospitals before technology took over. So these thermometers, the clinical thermometer has the same features as a common thermometer, but it has two extra features that are not there in a common thermometer. So we still have the bulb, we have the capillary bore, we have the glass stem, and we have the mercury. But if you look at this, you will notice we have two new features. Number one, we have a constriction. Like you can see, the capillary bore is not straight, it is bent. And then, like you can see, the scale does not begin from 0 to 100. It begins from 35 to 43 degrees Celsius. Okay, this is degrees Celsius. Now, why is this the case? Let us start with the scale. The scale is from 35 degrees Celsius to 43 degrees Celsius. Remember, the purpose of a clinical thermometer is to determine the temperature of patients. Now, the temperature of a human body should be between 35 and 43 degrees Celsius. In fact, above 40 is already so high. Now, the reason why the scale is different is because the temperature of a human body is around 37 degrees Celsius. So we don't need a scale that is beginning from, 0. Well, we're only going to measure a temperature around 37 degrees Celsius. So the reason why the scale is slashed between 35 and 43 is because this thermometer is used to determine the temperature of a human body, which is about 37 degrees Celsius. Now, the reason why it has a constriction is because if you go to a hospital that is still using this type of a thermometer, the thermometer is usually placed between, under your armpits. So the doctor places the thermometer under your armpits and then allows the mercury to move, to rise based on your temperature. And then, remember what happens in a thermometer, the mercury reacts to the slightest change in temperature. So the air around us has a different temperature to the one under your armpits. So if the thermometer is taken, to allow time for the doctor to take the reading, there is need for a constriction. Because without the constriction, the mercury will begin to flow back. Okay? It will begin to flow back to the bulb because the temperature in the air is less than the temperature in your body. So to prevent the backflow of mercury into the bulb, there is a constriction. So what happens is that the mercury above the constriction does not flow back to the bulb. only the mercury below the constriction. So this mercury here is held in that position, and the doctor is able to determine your temperature. Okay, so when the thermometer is taken from under your armpits, when the doctor wants to read the temperature, the constriction ensures that the mercury above it does not flow back into the bulb, because if it flows back into the bulb, then the doctor will not be able to take the accurate readings of your temperature, and that can be detrimental, because your temperature is very important when you're feeling unwell. It helps the doctor to be able to diagnose you. Now, when the doctor wants to take another reading, maybe to another patient, what do? They have, this is what they do to the thermometer until the mercury flows back into the bulb. So they shake the thermometer until all the mercury goes back into the bulb. And then now when they use it again, the same process continues. So the purpose of a constriction is to prevent backflow of mercury into the bulb before the reading is taken. Now, something else that is unique about this thermometer is that, now remember, this is in a hospital. So there is no way a doctor will use it on you and then proceed to use it with another patient without sterilizing it. So for sterilization of this clinical thermometer, you cannot use boiling water, because boiling water has a temperature of 100 degrees Celsius. If you dip a thermometer that can only measure up to 43, then that heat will be too much and the clinical thermometer will break into pieces. So to prevent that, a clinical thermometer is sterilized using methylated spirit. Okay, using methylated spirit. So we cannot use boiling water, because boiling water has a higher temperature than 43 degrees Celsius, which will make the glass of the clinical thermometer to break. So I hope you have learned something interesting today about the clinical thermometer. So the other type of thermometer is known as 6's minimum and maximum thermometer. Now the third type of thermometer is the 6's maximum and minimum thermometer. This thermometer is used in weather stations, and it is used to record the least temperature achieved in a day and the highest temperature achieved in a day. The minimum temperature and the maximum temperature, hence the name maximum and minimum thermometer. Now what happens is that, like you can see in this thermometer, we have two. It's formed using a U-tube. This is a U-tube. On this side we have a bulb, and then we have alcohol in this bulb. We have alcohol on this side. We also have alcohol here. At the top here we have air and alcohol vapor. The right at the bottom is where we have mercury. So mercury is holding the alcohol on either sides. Now when temperature begins to rise, the alcohol in this side becomes heated, and when it is heated, it expands. And upon expanding, it needs more space to occupy. So what it does is that it pushes the mercury on this side lower. Okay, the mercury is pushed lower on this side, but since it will also need space to occupy, the mercury on the other side now goes higher. So when it goes higher, it pushes the index with it to a certain level, to the highest level possible, because remember, the alcohol will be expanding when there is temperature. So when the highest temperature is reached, the mercury is pushed and it pushes the index with it and has it to the highest level. Now remember, temperature is definitely going to decrease as the day goes along. So this index is made of metal, and when the mercury begins to drop now, the index is left at a particular position. And that is how the maximum reading for the day is able to be taken. Now when temperature begins to reduce, the alcohol on this side of the U-tube begins to contract. And when it contracts, it reduces in size. So the mercury on this side will begin to go up, okay? Because more space has been created by the reducing alcohol as the alcohol contracts. So as this mercury goes up, it also pushes index B, okay, to a certain level, and it gets to the highest level possible. The minimum reading of the day or the minimum temperature is able to be taken, because remember, for this index to be pushed, the temperature has to be low at the lowest point to make the alcohol to contract and allow the mercury to move up with the index, okay? So the maximum reading is taken from this side of the YouTube, and the minimum temperature reading is taken from this side of the YouTube. Now at the beginning of the day, the two indices will be reset to their initial positions, and they are reset using magnets because they are made of steel. So a magnet is placed on the side and the index is pulled to a particular location. Same case on this side. So that is how a 6's maximum and minimum thermometer works. It is used to determine the minimum temperature reached in a day and the maximum temperature reached in the same day. So lastly, we are going to look at the bimetallic thermometer. Finally, we have a bimetallic thermometer. So this bimetallic thermometer, if you can remember well, in the topic of thermal expansion still, we learned about the bimetallic strip, which is formed using two metals that have different linear expansivities. So we noticed that when you hit a bimetallic strip, then it curves, okay? It doesn't increase in size in a straight way, it curves. So in this bimetallic thermometer, we have the bimetallic strip, and then we have a pointer fixed on this end, and then we have a scale here. So when temperature increases, the bimetallic strip gets heated and it begins to curve and curl in the clockwise direction. So as it curves, the pointer is able to move along the scale and show the required temperature. Then when the temperature is reduced, it begins to curl in the anti-clockwise direction and the pointer moves backwards to the required point in the scale. So that is how a bimetallic thermometer works. It works on the principle of the bimetallic strip. So now we have come to the end of the topic of thermal expansion. I'll give you a few questions that you will attempt to test whether you have understood what we have learned in this topic. Now for your practice, you're going to attempt these three questions. State the properties of a liquid that is suitable to use in a thermometer. The number 2, convert 283 Kelvin to degrees Celsius. The number 3, state one advantage of alcohol over mercury as a thermometric liquid. So I hope that you have learned a lot in this lesson. Thank you for being in this lesson and see you in the next lesson. Bye bye.